In this lesson, we're going to talk about arithmetic operations and applications. Specifically, we'll identify which set or sets a number belongs to, perform arithmetic operations, compare numbers using inequalities, and use arithmetic in some application problems. First off, types of real numbers. Natural numbers are positive whole numbers, not including zero. So 1, 2, 3, 4, etc., etc. Whole numbers are positive whole numbers including zero, such as 0, 1, 2, 3, 4, and so on. Integers are positive and negative whole numbers, including zero. Rational numbers are any number that could be written as a fraction, which means fractions, repeating decimals because they can be written as fractions, or terminating decimals because they can also be written as fractions. Irrational numbers are non-terminating or non-repeating numbers, such as pi or e, or a number that goes on forever and ever without repeating or without a pattern. Example 1. Determine which set or sets of real numbers the number belongs to. Now it's important to note, as you can see from the previous slide, that a number might belong to many sets, such as 2 is a natural number, it's also a whole number, it's also an integer, and actually it's also a rational number because it can be written as 2 over 1, which is a fraction. Okay? So when you're looking at which set a number belongs to, make sure you include all possibilities. So 15 is a natural number. It's also a whole number. It's also an integer. And it's a rational number. Negative 10, it's not a natural number because it's negative. It's not a whole number because it's negative, but it is an integer and a rational number. And again, it's considered a rational number because it can be written as a fraction. Moving on, 1.2. It's not a natural number. It's not a whole number. It's not even an integer, but it is a rational number because it's a terminating or it's a decimal that stops. And lastly, part D, we have pi, which is 3.14159 and so on and so on. Never repeats and never ends, so this is an irrational number. Next, we'll perform arithmetic operations. Arithmetic operations refer to addition, subtraction, multiplication, which could be denoted by x, parentheses, or a dot, and division, which you can either have the division symbol or a fraction bar actually denotes division as well. Example 1, different formats of addition and subtraction. So this could be a review for you. It might be something that you're comfortable with, but I'm going to show you a couple different ways to perform the indicated operation. So 2 plus 7, with numbers, and particularly in this class, because we'll be dealing with a lot of practical applications, I like to relate it to something, typically money. So if you have $2 and someone gives you $7, you'll end up with 9. You can also use a number line for this where you would start at 2, and since we're adding 7, we would go in the positive direction or to the right. 1, 2, 3, 4, 5, 6, 7. And if we were to finish this number line, we would end up at 9. For part B with 9 minus 2, again, think of money. If you have $9 and you give somebody 2, you'll have $7 left. Or on your number line, I'm going to write a vertical number line this time. It doesn't matter, you can do horizontal or vertical. Put 0 here. You would start at 9, and since you're subtracting, you would go down 2, and this would give you 7. Okay. Another way that you can think of this problem, and I'm going to use a different color, 9 minus 2 is the same thing as adding negative 2. On this number line, you would still go in the downward direction because 2 is a negative. Okay, so you could see this as 9 minus 2 or 9 plus negative 2. For part C, 3 minus 10, you have $3 and someone demands 10 from you, so you would be at negative $7 or $7 in debt. And the way that this looks on a number line, we would start at 3. So I'm going to put 0. You would start at 3, and then you'd go down, since we're subtracting, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you'd end up at -7. Okay. Again, you can also see this as 3 plus -10 if you prefer to think of it as adding a negative rather than subtracting. Example 2, different formats of multiplication and division. Part A, 2, the parentheses mean multiplication. 2 times -3 is -6. You can also see this as 2 times -3, or even -3 times 2. Order doesn't matter in multiplication. Part B, -4 times 5. This is use the closed dot to denote multiplication, and this is -20. Remember, for this class, you can use a calculator. So for the problems, you'll need to show your work for any in-class assessments and mini projects, but I encourage you to check your work on a calculator as well. For part C, when we have all this multiplication, -4 times 3 times -5, this is all being multiplied together. So you could start, let's say, with -4 times 3, which is -12, and then we'd still have it multiplied by -5 because we haven't taken care of that yet. So -12 times -5 is +60. For part D, 55 division symbol by 11. This could also look like 55 divided by 11. And when we're talking about division, we want to know 55 divided by 11 is equal to what, which is the same thing as asking 11 times what is equal to 55. Our answer here is 5. When we have -49 divided by 7, you can put the negative sign with the numerator or with the 49, and -49 divided by 7 is -7. Example 3, multiplication and division involving 0. Part A, 2 times 0 is just 0. Part B, 3 divided by 0. So what this looks like is 3 divided by 0, and what we just talked about with division equals question mark. So if we were to rewrite this as a multiplication problem, we'd want to know 0 times question mark equals 3. Does 0 times anything equals 3? You can try different options. 0 times 0 is 0. 0 times 3 is still 0. There's nothing we can multiply 0 by to get to 3. So in this case, our answer is undefined. You may also see it as a circle with a slash through it. And lastly, part C, 0 divided by 7 equals question mark. If we rewrite this, 7 times question mark equals 0. So what times 7 gives us 0? The answer here is 0. So I showed you the why because if we understand why, we don't have to memorize as much. When 0 is on the bottom, or when we're dividing by 0, our answer is undefined. When 0 is in the numerator, or we're dividing 0 by a number, our answer is 0. Example 4, simplify the expression. So these types of problems will appear in your homework. With my program, I am not able to show my screen, but what I would do is take one of your 2 approved calculators for this class, and you plug it in exactly how you see it. So where there's a negative sign, you can use the negative button, or you can use minus, and that's true for the other calculator as well. So I'm going to plug this in, -11 plus 2, or plus parentheses 2 plus 9, close parentheses -3. So as you can kind of tell, it's in my calculator exactly as it's written. Press equals, and we'll get -44. We don't talk about order of operations until a little bit later, so that's why I'm encouraging you to put this in your calculator for now. Part B is there because I wanted to mention that when you see these brackets, you can put them in as parentheses in your calculator. So 5 plus, so there's a bracket outside of 2, but notice I'm just going to put a parenthesis there. And you can have double parentheses, like what will happen with this problem. Just make sure to close everything out. So we have 5 plus parenthesis 2 plus 3 parenthesis 6 minus 2, close the parenthesis, minus 8 parenthesis, and we come up with 11.